Welcome to the lecture on special sand molding processes, and in this lecture we will discuss about processes based on organic binders. So, in the last lecture we discussed about the processes based on inorganic binders, and we discussed the binder being sodium silicate, and we had discussed about different processes. Now, in this lecture we will discuss about those binders which are based on organic materials. So, what happens that for production of high quality castings, earlier we used the inorganic binders only, but in those cases the cores which you make, they are normally quite big and heavier, they take also time. So, you use to make only the cores normally from these improved processes. Now, with the use of organic binders, basically you can make the cores of good strength. Normally you can make a light core with a small thickness, but having good strength and good properties. So, in those cases these organic binders are used. Even in casting also you can have the mold of lighter weight, and for quality castings you can use these organic binders to make the cells. So, these cells, even if they are having small thickness, they have adequate strength. So, among the varieties we have cell molding, hot box, cold box molding, alkyd and phenolic no-bake, furan and gas setting resin processes. So, these are the different types of processes which are used, and they are based on the use of organic binders. Let us come to the cell molding process. So, it is based on the concept of a cell building. So, what we do is, here basically you have a pattern plate, on that you have pattern is fixed, and this pattern is heated, and sand resin mixture is basically put on that pattern. So, what happens that when it comes in contact with the heated pattern, there is polymerization taking place, and then there is an amount of thickness of the cell is generated. So, what happens after certain time, you are basically inverting, and then you are getting 1/2 of the mold being generated by and in the form of cells. So, you have fine sand and you are using the thermosetting resin. Mixture is placed against a heated pattern, resin and sand grains are bonded to each other. After some time, pattern is turned over to allow unbonded sand to be removed, leaving cell of required thickness on pattern, and machines are available for core making and molding. So, what happens that you have a sand resin mixture. So, sand is coated with the resin, and this is the pattern. So, this is heated. So, once this coated sand comes in contact with this heated pattern, there is, because of the high temperature, the polymerization takes place and their bonding takes place. So, because of that, slowly with time a thickness of the cell is formed. After some time, after a predetermined time, this is again inverted, then these unbounded sand particles, they are left over in this portion, and you get 1/2 portion of the mold or the core be it. So, this way you can get the halves, either drag or cope portion of the cell, and this can further be assembled and put in the flask, and further you can have something to support it, because these cores, these cells are having very small thickness. So, they may not be able to withstand the metallostatic pressure. So, what you do is you are supporting it from all the sides, and then further you are pouring. So, this way what happens here that, so that is why it is known as cell molding, because with time a cell is formed and the pattern is heated, and because of that heat this is taking place. There are some methods. So, here basically you have two types of boxes used, core and molding methods used. One is dump box type and another is blow type. So, one for low production rate and another is for high production rate, manual and this is for mechanized, where the blowing takes place by machine. So, you will have large production rate. So, in this basically resin is thermoplastic type plus you are adding certain polymerizing agent, so that you get this thermosetting characteristic. Normally phenol formaldehyde is the resin which is used. The control hardening action, and to accelerate you are adding the hexa, that is hexamethylene tetramine. So, that is working as a catalyst, so that the hardening action is accelerated. Resin is about 4 to 6% by weight of sand, and hexamine is taken as 14 to 16% of that of the resin. So, this way you can have the composition that you take some sand and 4 to 6% of the weight of sand will be the resin, and then that is phenol formaldehyde, and further of the amount of the resin 14 to 16% is taken as this catalyst, that is hexamine. So, quality of resin will increase with fineness of sand. Sand should be free of clay, because clay is increasing the amount of binder to be used. So, that is why clay is not required to be in the sand. You try to have a sand which should be free of clay. You also use a large number of additives like coal dust, manganese oxide, ammonium borofluoride, lignine and iron oxide. So, they are providing you the specific objectives in attaining like resistance to thermal cracking, surface finish, resistance to distortion and strength increase. So, you have to add these additives to so that you get these specific properties. Now, to facilitate the release of the pattern from the mold, you are also using certain release agents. So, some lubricating materials like zinc stearate, calcium stearate or Carnauba wax, these are basically used so that there is not much of the sticking of the pattern with this cell developed, and that is why these agents are used. Now, the sand resin mix is basically made in 3 different ways. So, that coating of the resin on the sand takes place in 3 ways. One is hot coating, warm coating and cold coating process. Now, the name indicates that it is basically related with certain temperature, which is the operating temperature. Let us see one by one. What is hot coating process? So, in this hot coating process basically the sand mass which is given, this sand mass is heated to certain temperature like 120 to 175 degree centigrade. So, curing of resin due to dual effect of heat and chemical action of acid catalyst such as hexamine. So, heating dries silica sand to temperature of this and cooling the sand mix to 45 degrees C to prevent lump formation and flowability increases. So, what happens in this case, that once you have the sand coated with resin and once you are blowing on the pattern to this then in that case this sand mix itself is heated. So, what happens, due to this heat the polymerization takes place and it forms a solid mass. So, in this case there is no need to invert, as we have seen in the case of cell molding we are inverting, so that the sand which has not stuck to the pattern, they are basically left over and you can take them out. So, in this case this method of turning over is not required. Basically you are giving that much quantity of sand which has to form that cell. So, this sand mass itself is heated to 120 to 180 degree centigrade or 175 degree centigrade, and then due to that temperature it hardens quickly and forms a spongy hard mass. So, that is why it is known as a hot coating process, because you are heating to certain temperature. This is used for mass production because less resin is required, you are heating to certain temperature, and because of the heating polymerization is taking place. Then warm coating, because you try to avoid this heating. So, warm coating, the heating is done maybe moderately to the level of 80 degrees centigrade. So, in this case resin is in the form of a liquid solvent solution. So, in this case catalyst is used with different resin formation, so that curing is taking place at a lower temperature and you are using a liquid solvent. That is why, since it is done at a lower temperature zone, that is why it is known as warm coating process. Then last is cold coating, where it should be not be done at any temperature, but at room temperature. So, here sand plus hexa plus resin is dissolved in alcohol. So, that solvent is alcohol here and it is done at room temperature. So, basically it is more expensive because in this larger quantity of sand is required, but the problem of heating or that is reduced. So, in this case you do not need to go for heating and it is done at room temperature itself, but then alcohol, it has to be eliminated during mixing operation itself by blowing air. So, alcohol has to be, because alcohol, that way alcohol if it remains, that may be volatile and that may be dangerous. So, that is why in this case alcohol has to be eliminated before you are further mixing operation by. So, you are using the blowing air to remove the any trace of alcohol. So, the three methods are used for preparing the sand coat. So, sand resin mix and then they are used. Now, there are basically different tests which are done on these sand coat, and they are hot tensile test, it is done at different temperatures or at different time, maybe 1 minute and 5 minutes after that. Similarly, for melt point or stick point test, then hardness test. So, this way you do to ensure that your cell which has been made will come to the expectation of withstanding the pressures or forces of the metal. Now, pattern equipment is normally taken as a metallic pattern because it has to be heated to certain temperature of the range of 200 to 300 degree centigrade. So, you are using either aluminum alloy or cast iron, and that is used as a pattern material, and you can make the casting from 200 gram to 200 kgs in ferrous or non-ferrous materials. So, this way it is versatile process. You have many advantages of these processes, and you can see that sand prepared can be transported and stored easily. You have less sand required because you are making a shell which is very thin one and it has good sufficient strength. So, sand required is very small, and cores also are not required to be completely through or pure solid, basically they can be hollow also. You have good accuracy and finish, high rate of production with limited. So, in small space you can have high rate of production. Molds and cores, they can be stored for large amount of time because these molds and cores are non-hygroscopic. If you make the mold and core of normal inorganic binders, normally they are hygroscopic, they will absorb the moisture from the atmosphere and they get spoiled, but in this case that problem is not there, and it can be used for all the cast metals. Also, it has certain limitations, and the limitation is about its cost because you have to use a sophisticated equipment. Size and weight limitation is there, you cannot make a very large size or large weight material in this, and you need expensive equipment. So, you have to ensure that you are making the product in a mass scale, so that you can justify the amount which you incur on purchasing the equipment. So, these are the advantages and limitations of this process. Next is hot box molding. Now, in hot box molding, resin sand mix is blown over heated pattern or core box, not turned over, but sand heated and allowed to form sand mass. Now, in this case what is happening is, it is not turned over. So, resin sand mix will be blown over on the pattern, and then so it is a basically refinement of cell molding. Here in fact you do the similar process as cell molding, but here you are not inverting, you are blowing this resin sand mix and then you are heating in the box the sand mass, so that it forms a certain thickness of cell. In the cold box molding, in the box itself, in the hot box molding you are heating the sand mass, here you are not heating the sand mass and nor heating the pattern. Curing is by simply passing the gaseous catalyst through the sand mass. So, total time to prepare is very less, and sand plus the binder plus alkyd phenolic resin, and then this is the binder and this is the resin, and then in that basically the vapor is blown. So, this vapor, this TEA liquid atomized in air. So, this vapor working as catalyst, when it is blown in the sand mass containing binder, then it automatically does the binding operation and it makes a hard mass. So, this way hardness is achieved. So, hot box and cold box, these are the molding methods based on the temperature. Then one of the other variety is alkyd no bake sands. So, in that case basically as the name indicates, the baking is not required. In this case you use the normal drying oils. So, normal drying oils which are used for making cores, that is known as core oil. Now, in that case you are mixing these oils with certain resins. So, that is known as alkyd resins. So, they are formed by reaction of phthalic anhydride and glycerol. So, basically they are reaction product of petroleum, they are byproducts of petroleum making, and they are by reaction of phthalic anhydride and glycerol. So, what happens, the hydroxyl groups in this glycerol reacts with acid group in anhydride to produce large chains. So, what happens because of, so in earlier cases when we were making the cores and we were using the core oils, we needed to bake it, but in this case when you use the resins in these oils you do not need to bake it. So, because of the use of the reaction, because of this hydroxyl group reacting with the acid group, so they form a large chain, and due to the polymerization large strength develops. So, the sand system consists of binder, hardener, and hardener is cobalt or lead naphthenate. So, this is the hardener in this case, and in this case there is no baking. So, basically you are using a catalyst and that is isocyanate. So, this is the catalyst which is a poisonous gas, but it is used. So, once that passes the curing action takes faster. So, at fast rate the curing action takes place. Now, in this case you have a ABC system. So, what do you mean by ABC system? ABC system means you have binder, hardener, and then you have catalyst. So, ABC system means there is a, so binder is certain percent of the sand, then B is certain percent of the binder, and similarly C is also certain percent of the binder. So, this way you have A, B and C, binder, hardener and catalyst. Now, there are two ways, either, so ABC is binder, hardener and catalyst. So, either you can first mix A plus B and then plus C, or A plus C and then plus B. So, there are certain differences. This is giving you slow curing strength initially, but overall strength is higher in such cases, whereas it gives you initially good strength, but overall the strength will be moderate in such cases. So, you are basically coating initially with the binder and plus, so mixing the sand with this A plus B and then putting C, and in that case you have A plus C and then putting B, and this is how the two systems are used, but this is preferred. So, that is why A, B and C system is preferred. The other type of no-bake sand is, one is phenolic no-bake sand. So, in that phenolic no-bake sand, basically the advantage is that they are completely nitrogen free. So, in that case, once they are nitrogen free, they are well suited for production of steels. So, there is no probability of having any defects like pinhole porosities or so. So, these phenolic resins are normally used as binders in such system which is free of nitrogen. So, catalyst is para-toluene sulfuric acid or benzene sulfonic acid. So, this is the catalyst in these cases, and catalyst initiate further condensation of resin and advance curing by cross linking action. So, basically in these cases you have sand plus resin, that is your phenolic based resins, and plus you have catalyst like para-toluene sulfuric acid or benzene sulfonic acid, and they give you, without any baking, need of baking, you get a hard mass where you can further do the casting. Then there is another process that is known as Furon process. So, here you are furon resins, they are the core binders. Basically furon resins are used as the binders. So, these resins are urea furfuryl alcohol formaldehyde or phenol furfuryl alcohol formaldehyde. So, there are different types of resins which are used, and they give you strength based on different type of catalyst, and basically the advantage of such system is that you do not need any baking, and in these cases the dimensional finish is better, the time required is less, good productivity is attained. In this case the catalyst is phosphoric acid. So, this is about the Furon process. Then in the end this is a SO2 process. This SO2 process, here the SO2 gas is used. The problem is that in this case, because of the environmental concerns, this process is not preferred. So, here also again for the hardening action to take place, the SO2 gas is used, and since being acidic in nature, this is not very much preferred, but these are the different kinds of methods which are used for making the molds using organic binders, and they are used quite extensively for making of cores, because they take very less time. What needs to be mentioned is that in most of the cases the bench life is quite short. So, they are to be used, the flowability is quite good and bench life is short. So, they are to be used, production rate is quite fast. So, they can be used for mass production basis. Thank you.